Hello, my name is Karan Zukaria. My project topic for control system is the continuous stir tank reactor using Neuro-fuzzy controller. So there are a few outlines, but first I would go through the introduction. Here the gain scheduling technique is used to control a nonlinear system by decomposing the design of nonlinear and linear controller. Also, they have given the industrial name as continuous stir tank reactor. It has been used to demonstrate and assess the effectiveness of nonlinear control techniques and methodologies. The concept of using structural approximate function with traditional representative properties, let's say neuro-fuzzy controller, fuzzy system, and also a periodic controller to handle random continuous nonlinearity. These three components or controller techniques are used to handle the nonlinearity when it occurs while producing a chemical in the CSTR model. Let's talk about a bit about mathematical model. As we all know that designing a mathematical model today for CSTR is a bit difficult. Despite the fact that there have been many modeling strategies for CSTR, many of them uses linear approximation mode while some uses the nonlinearity. But the thing about nonlinearity is that it uses the AI, that is the artificial neural network, which have been used to model complex systems. If someone wants to make their design more complex, they would go through the artificial neural network technique, as it had achieved the great success simulating the dynamic actions of plant due to their strong learning capabilities. Now moving forward to the next slide, that is the neuro-fuzzy structure. This is the neuro-fuzzy structure that I have designed to implement it for the CSTR tank in my MATLAB software. So here I have designed the 5 rules to implement this neuro-fuzzy structure. The black circle says the input and output, whereas the blue one says the rules. And the white circle says the input membership function and output membership function. Let's talk about the model and table. Here on the left side we can see the inputs, their random values and their units assigned to them. On the right side we can see the CSTR model, and below is the formula, a mathematical formula for CSTR that I have implemented in my MATLAB software with the help of few advanced control system components. So let's talk about how this works. So first of all, we should know if we want a desired output from the CSTR tank, then it needs a continuous stirring in the tank. So that's what I'm gonna talk about. So first point says the exothermic and irreversible chemical reaction takes place in the tank reactor. Controlling the tank reactor's temperature is necessary to achieve the desired reactant temperature. To get the CSTR state to follow a specific temperature value, the ideal control law must be created. Although it is challenging to derive an ideal control law for the system, where QC is the coolant flow rate, Tj is coolant temperature, T is reaction temperature, and Ca is the product concentration inside the CSTR. So there are the 4 main methodologies. First would be feedback control system. So the main objective of this methodology is the CSTR water inside the tank, that we need to keep it at a predetermined temperature. The feedback control uses the temperature sensor to determine the actual value of the temperature by sending signal to the controller with the help of temperature transmitter. The next methodology is feed-forward control system. As CSTR application often requires constant changes in reactant rate and temperature affecting item outlet. For example, let's say sulfuric acid in the CSTR. If you want to produce a sulfuric acid, it needs a continuous stirring in the tank, and also it needs a changes in reactant rate. The best thing about this feed-forward methodology is that it eliminates the effect of change, and also it approaches the enables for feed-forward control, which anticipate disturbance. Now moving on to the third methodology that I'm gonna explain in my next video.